Welcome to video 11.5c. Again, we're in part 2, area of regular polygons in general. I've got two examples. This one's straightforward. This one's a little bit more challenging. We'll start with the easy one first. I've got a regular polygon, perimeter of 40, apothem of 5. Find the area. Just a straight shot of the formula. Area of a regular polygon equals 1/2 AP. The apothem is 5, the perimeter is 40, we're good to go. 1/2 of 5 by 40, 1/2 of 40 is 20, 20 by 5 is 100. So 100 units squared is the area. Okay, that was the easy problem. Now for the more challenging problem. I'll erase this just to give myself some more room. So what I'm going to do is I'm going to draw a large equilateral triangle and inscribe a circle on the inside. Alright, so let's see if I can do this. So that will be my equilateral triangle. I'll put the circle on the inside as best I can. Alright. Good enough, something like that. And what you want to remember is for an equilateral triangle, our angles were 60, 60, and 60. They said the circle has a radius of 6. This is where it gets complicated. The equilateral triangle has a radius, but then so does the circle. They're two different things. So let's keep in mind, this is the radius of the circle, and it's the apothem of the equilateral triangle. So I'll just say the apothem is 6. And I'm talking about the equilateral triangle. This is the radius of the equilateral triangle. And whenever you get a radius of an equilateral triangle, it's going to, or of a regular polygon, it's going to bisect that angle. So this angle here was 60. This little part over here is now 30. Let's focus our attention on this triangle right here. And one more thing, if we're tangent, we've got a 90-degree angle. So I've got a 90-degree angle here, a 30-degree angle here. This must be a 60-degree angle right there. Okay, so now I've got a 30, 60, 90. So again, just the ratios, 30, 60, 90, and the ratios were x, x rad 3, and 2x. So if opposite of 30 is 6, opposite of 60 will be 6 rad 3. And that's just this part right here. And again, that apothem, he's the perpendicular bisector, so this is 6 rad 3, this is 6 rad 3 here. I could have done the same exact work right here. I could have drawn that, you're 30, so same thing here. So this is going to be 6 rad 3 as well. Alright, I finally have the side of the triangle. So the side of the triangle equals 6 rad 3 plus 6 rad 3 equals 12 rad 3. And then if I wanted to, I could either use the formula for the equilateral triangle. I'll write that one down. So area of equilateral triangle was rad 3 over 4 s squared. So I could just square that and then multiply it by rad 3 over 4. But I'll just use the generic formula just to show you how that works. So the area of a regular polygon equals 1/2 AP. And again, that A value was 6. I need to get the perimeter. If one side is 12 rad 3, I can get the perimeter pretty easily. So the perimeter would be 3 times 12 rad 3 would be 36 rad 3. So now all I'll do is I'll substitute A is 6, P is 36 rad 3, and see what we come up with. Equals 1/2 A, 6, P 36 rad 3. And then 1/2 of 6 is 3. 3 by 36, well 3 by 30 is 90, 3 by 6 is 18, so 108 rad 3. And that would be units squared. And again, if you wanted to use this, you would have just put that in there. But be careful, it's going to be 12 rad 3 times 12 rad 3, which will be 144 times 3, and just be careful with your math. So there you have it, how to work out, I erased it, a simpler example for area of a regular polygon, and a more challenging example for the area of a regular polygon.